Just a second. Okay. All right. Hopefully it is recording.
It says it up top.
Fantastic. Okay, good. There it is. Okay, now I'm going to give you whiplash and share my screen with you again. Okay, so our learning target is I can describe how kinetic molecular theory explains the behavior of ideal gases. And so you probably have not heard about this before. The only real vocabulary word that we have for this is kinetic molecular theory. Let me explain what each of those things mean. So you guys, you know what molecular means. It means having to do with the particles that are involved in the gases and also in our world. Kinetic, guys, if I say kinetic, what's the first thing that y'all think of? Somebody's playing and doing a, what is that? Colby, what does kinetic mean?
Movement.
Yes, thank you. You're the only, I'm going to pick on you because you're the only person that I know. Yeah, kinetic means movement. So this is the movement of molecules. And there are 5 parts to this kinetic molecular theory. Now, Ms. Netherton is going to go over the specifics tomorrow. So I'm just going to introduce you to this. And this, I should not, honestly, it's not going to take anywhere near as long as her actually explaining the theory. But the point of this is to be able to explain how particle motion tells us about the behavior of ideal gases. Okay, I'm gonna stop sharing this and then we're gonna go to, I'm gonna start sharing another thing. Okay, so, guys, I'm sorry, it's not up there. Okay, so let me pull a window down. What I want to show you is the video from Google Classroom that we posted. And let's see if I can share my screen now with y'all. Okay. Okay, hopefully I can share with you now. Hi, Connor, I can see you now. My sister-in-law is from Michigan. Okay, good. Okay, there it is. All right. Okay, so if you look here on day 1 for our introduction, you have a video called Kinetic Molecular Theory. Oh wait, somebody's waiting. I'm gonna admit. Autumn. Autumn's excited. Okay, Autumn, hopefully you are coming in. So kinetic molecular theory, we've got this video for y'all. I'm gonna play it for you and then talk through parts of it. Let's see if I can get him to pop up. Okay, I'm gonna open it and make it big once he loads. Okay. Now, and then who hates Grammarly? Me. 5. Okay. Now, y'all can see that, right?
Yeah.
Y'all, I love this video. I know it's really silly. Kyle, you gotta be quiet. Okay, so let's talk about this guy. If you look at the video, there were a couple different things that they talked about. They talked about particles and them being in motion. If particles are cold, what happens to them as far as them moving?
They're slow.
Yeah, they get slow. And so guys, you can slow things down enough so instead of being a gas or a liquid, they will slow down enough so they can become a solid. So first of all, can we cool a gas down low enough that it turns into a solid form?
No.
Yes, you can.
Yeah.
You can take water vapor, and it's like with snow. You can take water vapor, and if you get it cold enough, then it will freeze into its solid form, which is ice. It seems really weird that you could take a gas like hydrogen and you could make it into, you could cool it down so it could be in a liquid form like for fuel, or it can even, turn into a solid form. You got to get it really cold. So this is something that, does not happen very, very easily. But so as far as the kinetics of things, the more energy that you put in, the faster that the particles are going to move. And when we talk about ideal gases, the kinetic molecular theory applies to all gases, and it applies to all types of matter. So gases are included. I don't know if anybody's explained to you what an ideal gas is. An ideal gas is just a gas that behaves perfectly. And the thing is, most gases, most regular gases, real gases as we call them, they behave like ideal gases, which is why we can use that ideal gas law equation to describe them, unless you cool them down really cold or you heat them up really hot. So at the extremes, real gases stop behaving like ideal gases. So I want to talk briefly about the 5 postulates of the kinetic molecular theory. And let's see if I can put them up for you. No, not there. Hold on just a second, you guys. Let me drive my Zoom. Okay. So, okay. So now I'm going to move this. Okay, there's somebody else waiting. Okay, so in kinetic theory of gases, so the kinetic molecular theory as it applies to gases, the molecules are really small and really far apart, and that matters for defining how a gas behaves. Gases, since they're so far apart, they're constantly in random motion. They collide with each other, and if y'all remember from the PhET online lab that you guys did, you saw that or if you watched really closely, especially the slow blue particles, as they moved toward each other, they were pretty slow until they collided with another one, and then their speed got greater. The key with ideal gases is those particles, the gas particles, they don't have any attraction for each other. And when they bump into each other, they don't lose any energy when they bump into. If we had particles that had some attraction to each other, what would happen? They would what? Starts
Come
with
together?
Yes, they would clump together. I was about to say starts with a C, ends with a lump. They clump together. Once things come together, they slow down their motion, right? Because they can't move as much. Yes? So instead of being a gas, it would clump together and it could become a solid or a liquid. The thing that does that is energy. Okay, Miss Netherton is going to talk more about the kinetic theory of gases as opposed to in relation to those 5 postulates tomorrow. What you guys need to remember from today is from that video that we had. What you need to remember from that video is just really, really simple, that all particles are in motion, and you should remember that from my very, very beginning chapters where you know that solid particles, even solid particles will vibrate just a little bit. All particles in motion, and that the energy is what determines how much in motion they are. So if you heat something up, it's going to have more motion and more collisions against the side of the container. Okay, so that's really, really just a little bit of information. Do you guys have any questions about that?
Not yet.
Okay, yeah.
Not really.
tomorrow, so the one thing that most people do get confused about is the word elastic. When we're talking about those perfect collisions where they bounce off of each other with just as much energy as they came in. So when Miss Netherton is explaining it tomorrow, you can just remember what elastic means.
Okay.
Hi, Autumn.
Hey.
Okay. If you guys do have any other questions, once you start looking at the videos and the instructional material, you guys feel free to email me or email your teacher who can help you too. And Ms. Netherton is going to do one tomorrow, and then later on in this week, Ms. English will do hers.
Okay.
All right, you guys, it was nice to meet you, all the people that I did not know. And you'll see Miss Netherton tomorrow. Autumn, Miss Netherton's going to do hers tomorrow.
Okay.
Go visit her.
All right.
You guys, if you have questions about any other assignment, you can stay here and ask me about them. Did anybody have any questions about the assignment from last week?
No,
No.
ma'am.
Did everybody do, did y'all do your scenarios? To
Yes.
make them good? Okay.
Yes.
I don't know if Miss Netherton and Miss English gave y'all comments to improve your scores, but
they did.
and Autumn, okay. So, okay. So it sounds like everybody's all good. All right. If you guys want to leave, I'll see you later. Otherwise, you can just tell me what you've been doing.
Bye, Kendall.
Bye.
Bye, Kendall. Bye, Emily. Bye, Tess. Bye,
Bye,
Autumn.
Dylan.
Bye,
Autumn.
Bye,
Everybody.
Emily.
I